Okay, the last topic of this chapter is about character and string. Okay, so in a C or C++, we can declare an str as an array of character. Okay, so str is located in DRAM like this, and the byte address start from lower to higher and higher and higher. Okay, and we declare and initialize str as a string of character with HELLO, and the last character is exclamation mark, but in reality H is capital H, E, lowercase l, lowercase l, and lowercase o, followed by the last one, which is the exclamation mark. So it's going up like this, and since it's a string, so the compiler will add a /0, which is also known as a null character. Okay, to specify that this is the end. Okay, because inside the memory something is already there, so to make sure that you don't get the junk, okay, these are junk characters inside the DRAM, inside the memory, so we want to make sure that this is the end. So the compiler put /0 as to specify that this is the end of the string. Okay, and the capital H is actually the ASCII code of capital H, which is 48 base 16 or 0x48. 65 base 16 is the ASCII code of the lowercase e, and so on. Okay, and /0 is actually 00 base 16. In other words, it's equal to 000000 base 2. Okay, so this is how the computer handles the string or the array of the character. Okay, if you are using a Unicode character, is going to need more space, at least 2 bytes, for example. So therefore, these 2 bytes will combine together with 2 bytes, these 2 bytes, like that. Okay, so in this section, we want to emphasize that the ASCII code is actually the first half, the top half of this table. Okay, how to read it? Here, this is the row number 0 followed by 0, so this is the null character. Okay, and this is 01, 02 all the way to 0f, and we start with the next row, so this is going to be 10, 11, if you can read it, 10, 11, 12, 13, 14. Okay, and we can double check. This is the ASCII code of the capital H, which is 48 base 16, and the lowercase e is 65 base 16. Okay, you can see this is row 5, row 6, column 5. Okay, so it's not a difficult one. But as I mentioned, Unicode is another table that overlay on the ASCII table. Okay, so what you see here, 0010, these numbers are the Unicode of this character. Just like capital H, 0048 is the Unicode of capital H. Okay, so Unicode just copy the 48 from the ASCII code and put 00 up front to make it the code of capital H. Okay, so if we continue down here, you can see these are Thai characters. Okay, Thai characters, and especially Unicode of Thai character 0E01, 0E02, all the way down to 00A0. Okay, so it's gonna be a little bit difficult for you to visualize ASCII code and Unicode on the same table, but this is what happened in real world. Okay, and we are going to do the lab 5 to show you that we are using Unicode for Thai characters on the web. Okay, on the web now. In summary, so we can apply these integers to be char, unsigned char for 8-bit. Okay, to represent character, to represent pixel like RGB, like black and white, grayscale images, or character for string, email, first name, last name, and so on. Okay, if you want something longer like 32 bits or even 64 bits, you can use unsigned int as pointer, as numbers, as general integer numbers, and so on. Okay, or you can use 16 to 32 bits of integer to represent fixed point real numbers, to represent audio, to represent pixels. Okay, and for the lower half, these are the floating point, IEEE 754. So remember, the single precision correspond to the 32-bit float data type, and the double precision correspond to the 64-bit IEEE 754. Okay, so you can use these data types to represent pixel in high definition images, to represent the distance in 3D games, and so on. Okay, so it depends on your application, what data types you want to use. All right. Okay. Thank you very much. Bye bye.